Look at question number 48 of 2014. When the resistance R2 in the circuit shown in the figure is varied from 0 to infinity, the potential of A relative to B will change from potential of A relative to B. So where is A? Here. Where is B? Here. Think simply. So potential of A relative to B will change. How does it change? So once again, when the resistance R2 in the circuit shown in the figure, R2 here, is varied from 0 to infinity, the potential at A relative to B will change from. Potential of A relative to B will change from. What do you say? When R2 goes from what? 0 to what? Infinity. Very simple. What happens here is this. Suppose R2 is 0. Before doing this, I taught you all a technique. What's that technique? We can make the potential at any point 0 by grounding it. So I'm going to ground this point. When I'm going to ground this, the potential at this point becomes 0. So continuously what? 0. Then if this is 0, this is V0. Therefore continuously what? V0. Very simple. V0, there we go. V0. 0, there we go, 0. First you'll do that, then things become very, very easy. It's nothing after all. So then, I'm going to do this. Let's see. Let's put R2 to 0. If I'm going to take R2 to 0, what's going to happen? I just have a conducting line. Wire. There's nothing, no resistance, therefore what? Continuously. Then can you see that this 0 is going to be B, potential at B, because the same line, 0, 0 plus 0, it goes here, and then potential at B is 0. But A, what's the potential at A? And we have V0 here, and we have 0 here. Remember at the very beginning I taught you in the first video. So I have V0, across how much of resistance? R4 plus what? R3. I have V0 across R4 and R3. Then how much is there across, for example, R3? Why am I getting the potential difference across R3? Very interesting now. I'm going to take the potential difference across R3, VR3, because potential difference across R3 is the potential at A itself. Why? So what is the potential difference across R3? VA minus 0. Got it? Therefore, that is what? Potential difference across R3. That is equal to potential difference across R3. That is equal to what? Potential at point A itself. Therefore, I can say V0, potential difference of V0 was available across R4 plus R3. Then how much across R3? So then we get the potential at A, first instant. So they're asking the question, the potential at A relative to B. Potential at A relative to B, that means VA minus VB. With respect to B, and therefore VA minus VB they're asking. Potential of A with respect to B, they're asking this, that is V. So what's the potential at A? V0 times R3 divided by what? R4 plus R3. That's it. So what is the potential at B? We found it, 0. Therefore, VA minus VB means this one minus 0. What's the answer? V0 times R3 divided by R4 plus R3. But now, the next one. Things get pretty interesting when R2 goes to infinity. That's the second instant they're talking about. What happens when R2 goes to infinity? These kind of questions I do in a very relaxed way. I do physics in a relaxed way. Don't take it to be complicated. I know that you've been told physics is a hard subject, things like that. No, it's not at all. Only thing, you have to love this subject and then just do it freely, in a free-flowing manner. Now, they say you are extending R2 to infinity. So let's do it. That means it's like having no connection here. Then can you understand that when you don't have a connection like that, what happens is this, that is, when you don't have a connection, there is no current going here, and it becomes zero. Then can you understand if the current becomes zero, because current can't continue along this path. That means V0 continues like this and goes to what? Point B. Can you see that? Therefore, we have what? The potential at B to be equal to V0. That's done. What's the potential at A? We found it. That is equal to what? Yeah, that was equal to what V0 was present across R4 plus R3. How much across R3? That was the value we found. Therefore, now we are asking for this value, potential difference. VA minus VB. Now, potential at A with respect to what? B. That is VA minus VB. Therefore, what is VA here? V0 times R3 divided by R4 plus R3. What's the potential at B? V0. Therefore, minus V0. Therefore, the answer is the fourth one. Pretty simple.